Unit 1, Lesson 7, Note 7, Functions, Day 1. Identify functions. A function is a relationship in which each element of the domain is paired with exactly one element of the range. So when we take a look at these two different examples, we have domain on the left and range on the right. These are mappings. And if you notice, every element of the domain has only one arrow or line to each element of the range. Over here as well, each element of the domain goes to one element of the range. It's okay if the range is repeated, but it is never okay if the domain is repeated. So in other words, your x values cannot repeat. So if we take a look at letter A, determine whether each relation is a function and explain. If I were to create a mapping of this, let's go ahead and do that. Our domain, we have 2, 3, 8, 8, and 9. So 2, 3, 8, and 9. Remember, we only write it once. Each number once, that is. Our range, 3, 6, 4, 7, 5. In numerical order, we have 3, 4, 5, 6, and 7. If we were to match our domain and range here, 2 maps to 3, 3 maps to 6, 8 maps to 4, 8 maps to 7, and 9 maps to 5. If we take a look here, this differs from our examples above. Our mapping on the left-hand side and our domain, the 8 is actually showing two different outputs, a 4 and a 7. Because this 8 value repeats, as shown here and here, because the 8 value repeats, it is not a function. And the proper explanation for this would be, no, it is not a function because 8 has two outputs. So let's go ahead and write that in. So again, no, 8 has two outputs. Letter B. This time I'm not going to show a mapping. We can actually just look at the ordered pairs. The same as if we looked at the ordered pairs over here, we would see that the 8s repeat here and here. So let's just take a look at the ordered pairs. So our ordered pairs, we have -4, 6, -3, 6, 1, 7, 5, 5, and 6, 10. I do not see any x values that repeat, but I do see y values that repeat. And if we take a look at the example above, it has y values that repeat, range values. And that's okay, it's still a function. We just can't have x values. So this one is a function because each input has its own output. Let's jot that down. So yes, each input has its own output. Letter C, we have a mapping. So again, your domain, each element in your domain can only go to one element in the range. And if you take a look over here, we have the 4, which is going to two different places. So again, this is not a function. It is not a function because 4 has two outputs. Let's jot that down. Go ahead and do D and E on your own. The vertical line test is used to see if a graph represents a function. If any vertical line passes through no more than one point of the graph of a relation, then the relation is a function. Determine whether or not each graph is a function and explain. So for the vertical line test, we need a vertical line. So I'm going to go ahead and draw a vertical line. Okay, so when I take this vertical line and I move it across the graph, if at any point the graph touches our curve at more than one point, it is not a function. So where my line is right now, it's only touching at one point. However, as I move my line over, you can see that it is touching at 2 points. One here and one here. Because it's touching at more than one point, it is not a function. So we would write, no, it fails the vertical line test. And we can go ahead and abbreviate that as VLT. So no, it fails the vertical line test. Let's go ahead and look at letter G. And I'm going to use our same vertical line. So let's bring it over. So again, I want to move it from left to right, and I want to make sure that it touches at only one point on our blue line. If the graph touches more than one point on the blue line, it fails the test. So let's go ahead. As I'm moving it along, I'm still touching at one point, and I'll move it a little faster. As you can see, it only ever touches our blue vertical line at one point. So this is a function. So we would say, yes, it passes the vertical line test. So yes, passes the vertical line test. Go ahead and try H and I on your own. Discrete versus continuous. A discrete function is a graph that consists of points that are not connected. A continuous function is a graph with a smooth line or curve. Another way to think about it is when you're drawing a curve or line, if you don't have to pick up your pencil, it's a continuous function. If at any point you would have to pick up your pencil, it would be discrete. So let's take a look at letter A. At an ice sculpting competition, each sculptor's height was measured to make sure it was in the regulated height range. The results are shown in the table. Graph the ordered pairs to the right. So let's go ahead and graph the ordered pairs. We have team number 1 had a height of 4. So team number 1, height of 4. Team number 2 at a height of 4.5. That one's a little off. Let's try that again. All right, that's about as close as I'm going to get that one there. Team 3 was 3.2. Team 4 was 5.1. And Team 5 was 4.8. Okay. Would it make sense to connect the points and explain? So we are talking about team numbers and the height of their sculptures. Would it make sense to make a line or any type of curve on this graph? For example, if you look at your x-axis, your independent variable, which is team number, if you take a look over there, would you have teams in between these numbers? So for example, could I have a team 1.5 or 2.3, etc.? The answer is no. So would it make sense to connect these points? No. So let's go ahead and explain that. So no, each team has one value. There are no values in between the domain values. And now, is it discrete or continuous? Well, we don't have a smooth curve connecting this, so it would be discrete. Try letter B on your own. I'm going to skip letter C. I want you to do that one on your own, but I want you to see letter D first. So letter D, height of a beam plant. The directions are: determine whether each situation would be discrete or continuous and explain. So we have a beam plant. The independent variable would be time in hours, and our dependent variable would be height. Also, the time would be the domain, and the height would be the range. So we're talking about a height of a bean plant. At 24 hours, the height was 0 centimeters. At 48 hours, the height was 0.2 centimeter, and 61.7 centimeter, and 75, 1 centimeter. So could there be a time in between, for example, 24 and 48 hours? Yes. What about 25 hours? 36 hours? There's definitely time that you could do in between. Meanwhile, we have to take a look at our height here. Could our height be in between 0 and 0.2? Well, the answer is yes. Because when a plant grows, it doesn't just jump from 0 to 0.2. It actually has to grow. So it would be between 0 and 0.2. It could be 0.1, 0.17, etc. It has to reach 0.2 somehow, which means it would be every height in between. So because it would be a smooth curve or line, we would say that this is continuous. So this is continuous. And the reason is that the function can be defined between the given domain values. An easier way to think about it is your time and your height, they don't have to be those exact numbers. They can be numbers in between. And again, I want you to go back and do letter C.